Hey everyone. So, have you ever really stopped to think about what keeps your heart ticking along day in and day out? It's actually this amazing natural electrical system. But what happens when that system starts to fail? Well, today we're going to dive into the pacemaker, a super tiny device that is the perfect example of how science, technology, engineering, and math, STEM, team up to fix the most important muscle we've got.
Yeah, seriously, it's true. Your heart isn't just a muscle that pumps. It's also this perfectly timed electrical machine. You can kind of picture it like a house with all this tiny wiring running through it, sending signals that tell it to beat, over and over again. And the craziest part? You don't even have to think about it.
All right, but sometimes that natural wiring can run into some trouble. So to really get what happens when it goes wrong, we first need to understand how it's supposed to work. Let's take a quick look.
So a healthy heartbeat is actually pretty simple. It's just 4 steps. It all kicks off with something called the SA node. Think of it as the heart's own little spark plug. That spark makes the top parts of the heart squeeze. Then the signal pauses for just a split second before telling the bottom parts to pump all that blood out to your body. So it goes spark, squeeze, pause, squeeze. That's it. That's a perfect heartbeat.
It's a really great system when everything's working right. But here's the thing. Sometimes, because of age or an illness, that wiring can get damaged. The signals might get weaker or even blocked, and suddenly the whole rhythm is just off.
When that rhythm breaks down, it often leads to a condition called bradycardia. Now, that's a big medical word, but all it means is that the heart is beating way too slowly. And if your heart is too slow, you're not getting enough blood and oxygen, right? That can make a person feel super tired or dizzy or even cause them to faint, and that can be really, really dangerous.
So if the heart's own wiring is broken, what do you do? How do you fix it? Well, this is where technology comes in and basically becomes the hero of the story. So let's meet the pacemaker.
So what is a pacemaker? Put simply, it's just a tiny little computer that runs on a battery. It gets placed right under the skin, usually on the chest, and it has one single job: to help the heart keep a nice, steady beat when its own system just can't do it anymore.
A typical pacemaker has 3 main parts. First up is the pulse generator. This is the brains and the battery, all packed into a really safe little metal case. Then you've got the leads. These are just really thin, flexible wires that a doctor guides right into the heart. And at the very tip of those wires are the electrodes. These are the super important parts that listen to the heart and deliver the little electrical signals.
Now, this is a really important thing to remember. A pacemaker only fixes a heart that's beating too slow. It gives it a little nudge to speed it up. There's another device called an ICD that does the complete opposite. It stops a heart that's going dangerously fast by giving it a shock. So 2 very different tools for 2 very different problems.
Okay, so we know what it is and what its parts are. But how does this tiny computer actually think? How does it know when to work? Well, it turns out it's all based on some really simple but really smart logic.
A pacemaker is basically always doing this simple 4-step loop. First, it senses. It's just listening all the time to the heart's natural rhythm. Second, it decides. It asks, hey, has it been too long since the last beat? If the answer is yes, then third, it acts. It sends a tiny, painless little pulse to get the next beat started. And fourth, it adapts, which means it lets your heart speed up when you start moving around and exercising.
Honestly, you can shrink a pacemaker's whole job down to this one simple line of code. It's just an if-then statement. If the heart is slow, then send a pulse. Else, do nothing. It's the perfect backup singer. It only chimes in when it's absolutely needed.
And remember that adapt step we just mentioned? Well, the fancy term for that is rate responsive. And this is what makes modern pacemakers so incredible. They have tiny sensors that can actually feel your body moving. So when you get up and run, the pacemaker lets your heart rate go up to give you more oxygen. And when you sit down to rest, it lets it slow right back down. This is what lets people live totally normal, active lives.
So, what's it actually like to live with this little computer in your chest? There are a lot of myths and scary stories out there, so let's clear things up and separate the facts from the fiction. All right, let's bust some myths. First, pacemakers do not shock the heart. Nope, they send tiny little pulses that you can't even feel. Second myth, you can't use your phone or a microwave. Wrong again. Most electronics are perfectly fine. You just have to be a little careful, like not keeping your phone in a pocket right on top of the device. And the biggest myth of all, that you can't exercise. That's the whole point. The pacemaker's there so you can get back to being active and living your life.
So you might be wondering, what about the battery? Does it need to be changed all the time? Well, you'd be surprised. These batteries are incredibly powerful and they last for many, many years. And when it is finally time for a new one, replacing it is a pretty simple procedure.
And get this for some cool tech. A lot of new pacemakers can actually be checked by your doctor while you're at home. The device sends all its information wirelessly to a special monitor, so your doctor can see that everything's working just right without you even having to leave the house. That means way fewer trips to the clinic.
Okay, so let's bring this all back to where we started. A pacemaker isn't just one invention. It's really the perfect proof of how powerful STEM is when all the different fields work together on a problem.
Let's just break down the team. The S, science, is how we understood the heart's electricity in the first place. The T, technology, gave us the smart sensors that can listen and react. The E, engineering, is what built the tiny, safe device with that long-lasting battery. And the M, mathematics, is behind all the perfect timing, calculating the milliseconds between each beat to keep it all humming along. See? It's the ultimate team effort.
And what's the result of all that incredible teamwork? It's simple, but it's so powerful. People with pacemakers get to live longer, safer, and way more active lives. They can play with their grandkids, travel the world, and just do all the things they love. All thanks to a tiny box of STEM magic.
So that's the pacemaker, a tiny computer powered by a whole team of STEM experts, keeping millions of hearts beating all over the world. It is such an amazing solution to a really big problem. And it kind of makes you wonder, right? What huge problem do you think STEM is going to solve next?